everyone, my name is Nitin and I'm a rising junior at Evergreen Valley High School. So for my starter project, I did a motion alarm which uses an ultrasonic sensor, a piezo buzzer and a servo, and when that sensor detects an object nearby, the servo will rotate and the piezo buzzer will beep. For my main project, I did the gesture controlled RC car with a robot arm, and I picked it because it incorporates electrical engineering and programming, so I thought it'd have the biggest impact on me. Here's a demonstration. So my whole car is controlled by my hand right here. When I bend my finger, my car can move in any direction. And when I make a fist, my servos will be enabled, which means now my hand will be operating my servo. So when I bend my finger now, okay, so it's still in motors. Wait, my pinky is weird. I can't bend it fully. So just wait. Yeah. Yeah. Okay. Oh. Okay. Yeah. So now I can control my servo. So for how it works, my RC car has two DC motors. These are used to just move the car. It also has two servo motors. These are used to operate the robot arm. And I have an NRF module on my RC car and on my glove. So the NRF module on my glove is a transmitter, and the one on my car is the receiver. So my NRF transmitter, it sends data packages to my receiver, and the data contains my flex sensor values. Flex sensors are variable resistors, and when bent, its resistance increases. When my receiver receives this data, my Arduino reads it, and depending on the values in the data, it would make my motors and servos run, basically. Okay, so for my challenges, it was basically the things I had no experience with, which was the NRF modules and the soldering. For my NRF modules, I had trouble to progress in the first few days because I had to research a lot to fully understand how it works. And then, still, trust me, I had to do a lot of troubleshooting even afterwards. And now soldering, I was terrible at it at the beginning. I had to restart my PCB board a couple times, but afterwards I got the hang of it and got a fully functional PCB board. And then next I'm planning on adding an ultrasonic sensor, which will make my RC car stop when it detects nearby objects. I'm also planning on adding an LED, which lights up so I know which mode it's on. So is it controlling the motors or the servos? And this blue stamp experience has been very educational and a lot of fun too. I was able to create my own engineering project from scratch to a finished product, and creating this product is very challenging, and I'm thankful to my instructors for helping me along the way. Any questions?
How does how does you move your finger and it moves, right? How do you control the distance? Like, for example, if you move slowly, does it move slowly, or if you do it fast, it goes really quick?
Actually, so I use the mapping constraint function. So when my value's in a certain range, my motors will just run at a constant speed. Okay. I didn't really change the speed or anything.
Okay, so if you move like this, it doesn't matter fast or slow.
Yeah.
It just moves. Okay. Awesome.
Does it matter if your palm is facing down or up, supinated or?
I have to bend my flex sensors downwards. Like if you see these squares, I have to bend it downwards. So if it's like this, then I have to do it like that. And
yeah, but it'll still have the same effect?
Yeah. Yeah.
So you convert from your servo to your motors by hitting a fist?
Yeah.
You convert back and forth?
Yeah. So I have this enable, so when I make a fist, this enable changes, and then I use if statements, so if the enable is a certain value, then it's controlling the servos or motors.
So how is your arm communicating to the motors?
Yeah, using this NRF module. So yeah, so this basically sends data packages, like I said, of the flex sensor values. And these flex sensor values are read by the Arduino, and then that makes the motor. It actually sends radio waves. It has something called Gaussian frequency shifting. So this it uses discrete frequencies to send digital information to the